Hi everyone. So yesterday we talked about the product rule. We had to take the product of two functions and find the derivative of those two functions. Today we're going to kind of go the opposite way, and we're going to use the quotient rule, which helps us to find the derivative of the quotient. So once again, what is the quotient rule? Quotient rule tells us how to differentiate the quotient of two functions. It's a little bit different. The quotient rule, when we are given f divided by g, which is function f divided by function g, and then we're finding the derivative of that, is going to be represented by function g times the derivative of function f minus function f times the derivative of function g, and everything is divided by function g to the power 2, or function g squared. So it's better to kind of show you in practice how this works. So let's take an easy example, like what is the derivative of cosine of x divided by x? Well, using the equation that we just expressed a moment ago, we can write this as x, which is our g, times cosine x prime, which is f prime, minus cosine x, which is f, times x prime, which is g prime. And then the whole function will be over x squared, which was g squared. So if we do each of these parts individually, we know that x would stay the same because we did not take the derivative of that function. Cosine x prime, or the derivative of cosine x, becomes negative sine of x, minus cosine x stays the same, times the derivative of our g, which was x. And the derivative of x is just 1. On the bottom, we just have x to the power 2, which is just x squared. So then, if we clean up our function, we would just get something simple like negative x sine x minus cosine x. This is because x times negative sine x is just x negative sine x, or negative x times sine x, minus cosine times 1, which is just cosine of x divided by x squared. So now let's take a look at this in another way. Here's a more theoretical way to think about it. We have d over dx of u divided by v, where we have v times the derivative of u minus u times the derivative of v, and everything's over v squared. Or you think about it as d over times uv, which is v du minus u dv, all over v squared. So that's 3 different ways I showed you how to express the quotient rule. Now, if you didn't like that, and if you find it a little bit confusing, there's a little bit of a song we can sing. So some people like to say low d high minus high d low, all over low squared. Now, what does this mean? Well, the low d high means the lower function, which would be v. Then you have the d, which is derivative of the high function. So low d high. So it's a lower function, derivative of the higher function, minus high d low, which is the high function, times the derivative of the low function, high d, and then low, the lower function, all over the lower function squared. Low d high, high d low. So let's take another look at this one. So here we have the derivative of 2x to the power 3 plus 5x divided by the function x squared plus 3. Obviously, in this situation, our function f is going to be the 2x power 3 plus 5x. Our function g will be x squared plus 3. So I went ahead and already kind of did most of this. So if we take our g, or in this case our v function, which was just x squared plus 3, we're going to take the derivative of the top function, which is u. The derivative of 2x to the power 3 plus 5x is 6x squared plus 5, minus our u function, which was the top, which was just 2x cubed plus 5x, which is right here on the top, times the derivative of our v. Well, x squared plus 3, the derivative of this would just be 2x. And that's going to be all over our bottom function, our v, which is x squared plus 3 to the power 2. Now, we don't have to go further than this. Today, we can kind of just leave it once we have set it up. You don't need to simplify it. You don't need to go further with it. We can leave it compact and less messy this way. I just want you guys to get used to kind of using the quotient rule functions on your functions. That's about it. So But just in case, let's go over one more example where we kind of show you how to kind of simplify. So here we have the derivative of this another quotient, which is t squared minus 1 divided by t squared plus 1. In this case, our f function would be t squared minus 1. The g function would be t squared plus 1. So remember, low to high, high to low. Our low function would be t squared plus 1. Our high function would be t squared minus 1. So if we think about this, our low, t squared plus 1, pops right in. Then we take the derivative of the high function. The derivative of t squared minus 1 is just 2t, minus high, which is t squared minus 1, times the derivative of the lower function, the low, which would also be 2t, all over the low function squared, which is t squared plus 1 to the power 2. Now, if we wanted to clean this up a little bit, we could. Obviously, if we multiply t squared plus 1 times 2t, we get 2t to the power 3 plus 2t. T squared minus 1 times 2t is 2t to the power 3 plus 2t. The bottom stays the same. And if we clean that up, we would just be left with 4t. Now, we don't typically have to simplify everything in every equation. If you'd like to, you can, but you can kind of keep it simple for today. And that's the general idea on how we use the quotient rule. So that's going to bring us to today's activity. So today's activity is my turn, your turn, where you guys are going to have to take turns telling each other what to do. So I'm going to give you guys one pencil, not a pen, a pencil, to use between the two of you. Only one person is allowed to use the pencil at a time. How this is going to work is that we have partner 1 and partner 2. You're going to put both your names in either column. Partner 1 is responsible for all the problems on the left. Partner 2 is responsible for all the problems on the right. But there's a caveat to this. Partner 1, who has the pencil, cannot write anything down unless partner 2 tells them explicitly what to write. So even though partner 1 has the pencil, they can only write down what partner 2 tells them to write down. So partner 2 will then explain to them how to use the quotient rule on this problem. Now, partner 1 is not allowed to go ahead and go, oh, well, I know what to do, and start writing it out. Nope, that's not what this is about. It's a communication game. So partner 2 is going to explicitly explain what they have to write down. So partner 1 is not allowed to write anything unless they are told to. Now, if your partner explains something incorrectly or you might disagree with their mathematics, you can always say, hey, I don't think that's right, but please be polite to your partners. Then once one problem is done, you will switch to the pencils, and then partner 1 will tell partner 2 how to solve the problem or how to set it up, etc. And you guys can go back and forth across all of these problems for today. Now, if you get to the bottom, it says stop, raise your hand so that myself can come there and check your work. If you have any questions, let me know because I'm here to help.